Okay, our fifth subtopic, which is on forces between two parallel current carrying conductors. So in this subtopic, you should be able to explain magnetic force per unit length of two parallel current carrying conductors, and lastly derive and use magnetic force per unit length. Okay, force per unit length. So let's consider these two identical straight conductors, 1 and 2, carrying current I1 and I2 with length L placed parallel to each other. Okay, so the conductors are in vacuum and the separation is D. The magnitude of the magnetic flux density at point P here on conductor 2 due to conductor 1 is given by this equation here. Okay, so the direction of the magnetic flux density is gonna be going into the page, and then conductor 2 carries a current of I2 and in the magnetic field B1, hence conductor 2 will experience a magnetic force of F12. Okay, force by 1 on 2. Okay, so the magnitude of force by 1 on 2 is then given by this equation here. Okay, so the magnitude of F force by 2 on 1 pula, do the same thing and you'll get this equation here. So in conclusion, both F12 and F21 is actually equal, so we can just let it equal to F lah. Alright, and the type of the force here is an attractive force. Okay, so from this equation we then get the force per unit length punya equation, which is this one lah. Okay, alright, so if the direction of the current in conductor 2 is changed to upside down, so the direction of the current for this wire are in the opposite direction, the conductors will be repelling each other. Okay, so the forces, the magnetic force will repel each other. Okay, so if they are in the same direction, it will attract each other. Okay, so the magnitude can be determined by using this equation here, and the direction can be determined by applying the Fleming's left hand rule. Okay, so as a conclusion, the type of force for when the direction of the current is upside down, the force is repulsive. Okay, alright. Okay, so that is basically the theory part for our fifth subtopic.